This is the first lecture on class 12 maths chapter 2, which is inverse trigonometric function, and in this video I will be discussing the topics inverse trigo function, that is the basic idea about inverse trigonometric function along with the graph, and principal value branch of inverse trigonometric function, then domain and range of inverse trigonometric functions for the principal value branch, and then some properties which we need to find the principal values of functions given. And in this video all the questions related to finding principal values I'll be solving, which will be covering the whole exercise 2.1 and some questions from 2.2 and also from miscellaneous, all those questions related to finding principal values. Now the first topic going to explain is what is inverse trigo function, and I'm starting with the sine function. And at first I'll draw the graph for sine x, fx equal to sine x. And x I'm taking the values 0, pi by 2, pi, 3 pi by 2, 2 pi. And here along x-axis I am taking length of equal intervals of pi by 2. Pi by 2, then again 2 pi by 2, 2 pi by 2 will be pi, 3 pi by 2, 4 pi by 2, that is 2 pi, then 5 pi by 2, and so on. And even in the negative direction it will be minus pi by 2, minus twice pi by 2, that is minus pi, minus thrice pi by 2, and so on. Then we have learned the corresponding values of sine x, fx equal to sine x. The corresponding value is 0, 1, 0, minus 1, 0. And we can see x values pi by 0, pi by 2, pi, which I'll put along x-axis, and the value of fx, that is sine x, I'm going to put along y-axis. And we can clearly see the fx values, minimum is minus 1, maximum is 1. So I'll take fx value, we have to put along y-axis, fx is along y-axis, and x value is along x-axis only. Then along fx we can see fx, that means y, along y-axis value minus 1 to plus 1. Then I'll take here minus 1 and here plus 1. That means the values of fx cannot go beyond of minus 1 and plus 1. So I'll draw like this. The value of fx cannot go beyond of this line. Now first point, you see when x is 0, fx also 0, that means 0, 0 is the origin point. Then when at pi by 2 fx value is 1, at pi by 2 fx value is 1, the point is here. At pi it is coming to 0 again. At 3 pi by 2 going to minus 1, at 3 pi by 2 corresponding value is minus 1. Then at 2 pi going to 3 pi by 2 is here, corresponding value is minus 1, and at 2 pi going to 0. Now if we join the points, the curve is like this. This is the curve, and this curve can be extended in the negative direction and also can be extended in the positive direction. Along x it can be extended indefinitely in positive direction, and also it can be extended indefinitely in the negative direction. But along y it varies from minus 1 to plus 1, and along y variation is called range. And along x see the variation is up to plus infinity and here minus infinity. So minus infinity to plus infinity, it is the domain of the function. So this is the graph for sine x, fx equal to sine x. Now we can very clearly see here at pi by 2, I'll just take some particular points for explaining. I'll take this pi by 2, at pi by 2 fx value is 1, at 5 pi by 2 also fx value is 1. That means f of pi by 2 is equal to 1, f of 5 pi by 2 also is equal to 1. You see, at pi by 2 it is going to the maximum, that means value is 1, at 5 pi by 2 also going to maximum, value is 1. Now if I draw Venn diagram, which we have learned in chapter 1, pi by 2 having image 1 and 5 pi by 2 also having image 1. Two different values of x, this is fx, two different values of x having the same image. That means the function is not 1 1, the function is many 1. A function which is not 1 1 cannot have inverse. For a function to have inverse, the function must be 1 1 and also 1 2, but here we can very clearly see the function is not 1 1 because at pi by 2 and 5 pi by 2 corresponding values of fx are same. Pi by 2 having image 1, 5 pi by 2 also having image 1. However, if we restrict the domain between minus pi by 2 to plus pi by 2, if we restrict the domain between minus pi by 2 to plus pi by 2, then see at every point the value of fx is different. The height of curve for every value of x, the corresponding height of the curve is different. That means the function will be 1 1 and 1 2, and in that case we can have inverse. That means this domain, if we restrict to only minus pi by 2 to plus pi by 2, then we can have inverse of the function. And range will remain same, range will be minus 1 to 1. We can very clearly see even between minus pi by 2 to plus pi by 2, along y the variation is minus 1 to plus 1. So restricted domain now minus pi by 2 to plus pi by 2, and restricted range is minus 1 to plus 1. Now I'll come to the second part, that is inverse of the function. So what we understood is within minus pi by 2 to plus pi by 2, the curve, the function is having for different values of x, different values of y. That means the function is 1 1 and 1 2, and it can have inverse. So with this range, this is the restricted domain, with this domain taking range and with this range taking domain. Domain means along x and range means along y. Now I am going to draw the graph for the function fx is equal to sine inverse x. When we invert the function, this domain will become range for inverse function, and this range, restricted range, range is minus 1 to plus 1, domain is restricted. The restricted domain is becoming the range of the inverse function, and the range of sine x is becoming the domain of the inverse function. And then what kind of curve we will get, let us see. Along x now, see domain is along x, variation is between minus 1 to plus 1, variation is between minus 1 to plus 1. So I'll mark here along x we cannot go beyond minus 1 to plus 1. So I'll draw like this. The curve cannot go beyond of this area. Then along y range, variation is minus pi by 2 to plus pi by 2. So I'll put here minus pi by 2 and plus pi by 2, and then you can see for minus pi by 2 corresponding value is minus 1. So for minus pi by 2 we are coming to minus 1, minus pi by 2 corresponding minus 1, point will be here, and for pi by 2 corresponding value is 1, so it will be somewhere here, and then if we join, the curve is like this. So this is the curve between minus pi by 2 to plus pi by 2. This portion is called principal value branch for the inverse trigonometric function. However, this curve can be extended in both positive and negative direction. Curve can be extended, but we have to keep in mind between minus pi by 2 to plus pi by 2, this portion is the principal value branch. Now this portion is the principal value branch for which we have restricted the domain of sine x between minus pi by 2 to plus pi by 2, and we have seen between minus pi by 2 to plus pi by 2, if we restrict, then only function is 1 1 and 1 2, then it can have inverse. Then again between pi by 2 and 3 pi by 2, if we take this domain again, the function also will have inverse. Then 3 pi by 2, 5 pi by 2, in between 3 pi by 2 to 5 pi by 2 also the function will have inverse. But we will not go to that part, only we are going to take the restricted domain between minus pi by 2 to plus pi by 2, then we get the principal value branch of the inverse function like this. Within this, between minus pi by 2 to plus pi by 2, this is the portion which is called the principal value branch of the inverse function. So in this video I am not going to explain the graph for other trigonometric functions, for which I will make separate video, and in this video now I will be mainly focusing on solving problems about problems on finding principal values of trigonometric functions, inverse trigo functions. To find the values of principal values of inverse trigonometric functions, we must know at first about this trigonometric values of the trigonometric functions, which we have learned in class 10, class 11 also. These are the values given, nothing to explain, you have to memorize. You find out some pattern tricks to memorize. And second thing, you must know the domain and range of principal value branch of inverse trigonometric function. Sine inverse, domain is -1 to +1. Domain means values of x and range means values of the function fx. For sine inverse -1 to +1 and domain, and range is -π/2 to +π/2, close interval. You have to memorize this domain and range for inverse function. Mainly we need to know the range, and no need to memorize blindly. I am going to explain, I am going to give it tricks very easily. In few seconds we can memorize these ranges. I am going to explain now how to memorize these ranges of the inverse trigo functions for principal value branch. To find the principal values, we need to know a property, and I am going to explain property for negative x. In few seconds you can memorize. You memorize like this: cos inverse minus x, cos, sec and cot. These three one group. Cos, sec and cot one group, and remaining is what? Remaining is sine inverse minus x, sine, cos, tan inverse and cot, sec, cosec. You make a group like this: cos, sec and cot one group. Their range is only 0 to pi. Their range is only 0 to pi. Cos, sec, cot, range 0 to pi memorize, and remaining is range -π/2 to +π/2. And how to write, when to write open interval, when to write close interval, I am explaining. First you remember, for cos, sec and cot 0 to pi, and remaining is -π/2 to +π/2. And the property is like this: cos inverse minus x is pi minus cos inverse of plus x. Same here also, pi minus sec inverse of plus x, pi minus cot inverse of plus x. So these three, they are in pi minus group, but in the other three you can directly take minus. So sine inverse minus x is minus sine inverse plus x, minus tan inverse x, and minus cosec inverse x. You see the difference here. Pi minus these three, cos, sec and cot, memorize cos, sec and cot, pi minus, and remaining directly we can take out minus. And for these three, range is 0 to pi. For these three, range is -π/2 to +π/2. So I'll write the range. You see, I'll write the range for this part. I'll erase, I'll write here again. Their range is 0 to pi. Close or open, I am explaining now how to understand here. And this one I'll erase, I'll write it here. Their range is -π/2 to +π/2. This is their range. Now how to write, you see, for sine, range will be -π/2 to +π/2. It will be close interval. Close interval, because at 90 degree, you see, for sine at 90 degree it is defined. For tan, range will be -π/2 to +π/2, and for tan 90 degree not defined. When not defined, interval will be open. For tan, interval is open, because tan 90 at pi/2, tan not defined, you see. Cosec -π/2 to +π/2, cosec 90 degree is defined, so it will be close interval, but cosec 0 is not defined. In between 0 is there, so we have to reject 0, so -0. This is the range for cosec inverse. Then for these three we know 0 to pi. Now how to write open, how to write close interval? You see, for cos, range will be 0 to pi. It will be close interval, because 0 to pi. At 0, you see, at 0 cos is defined. We can take any one extreme point, 0 we can take, cos 0 is defined. For sec also it will be 0 to pi. Sec 0 is defined or not? Sec 0 is defined. So it will also be having close interval, but minus, you see, pi by 2. Sec pi by 2 is not defined and pi by 2 is in this, so we have to reject pi by 2. So this will be the range for sec inverse. And for cot inverse, what will be the range? Cot 0 is not defined, so it will be 0 to pi, it will be open interval again. So these are the range how to memorize. You see, only at the point at which not defined, the interval is open. This one at 0 not defined, interval open. This one at pi by 2 not defined, 10 pi by 2 not defined, 10 pi by 2, 10, 90 not defined, so open interval. And in between, if there is a point at which the function is not defined, that point is rejected, like cosec. At 0 cosec is not defined, you see, cosec 0 not defined, so we have rejected 0. Then sec pi by 2, sec 90, sec pi by 2, you see, it is not defined, so pi by 2 rejected. So this is the way. In a second you can memorize. I am telling you once again, you memorize like this: cos, sec and cot one group, pi minus group, and remaining directly minus can take out. And this is how we memorize the range. With the help of this property, you can memorize the ranges of the principal value branches of inverse trigo functions, 6 inverse trigo functions. Then, so this is we can write it first property. This property just now we have explained, and to find principal value you must know one more property. You can write it property 2. It is like this: sine inverse sin x is equal to x. Sine inverse and sine gets cancelled. Similarly, cos inverse cos x will be equal to x. Cos inverse and cos cancel. Tan inverse of tan x will be also equal to x. That means every function and its inverse gets cancelled. Sine inverse sine cancel, remaining only x. Cos inverse cos cancel, remaining x, like this. So only these two properties we must know to solve the principal values, which will cover whole exercise 2.1, some from 2.2 and some from miscellaneous exercise. So only these three you must know. This table, which is from class 10, this property you should know, and this property also you should know. Then any question on principal value easily we can solve. Now I am solving questions to find principal values. To find principal values, I am taking for all the 6 ratios, I am taking two questions, one with positive value, another with negative value. Now you see, first one, sine inverse 1 by root 2, it is positive, and when the value of x is positive, then you have to do nothing, only you have to choose the angle corresponding to 1 by root 2. You see, in sine 1 by root 2 is pi by 4. So I can write here sine pi by 4. Then according to this property, sine inverse sine gets cancelled, then answer is pi by 4, and this is the principal value of the given function. Now when negative, then we must apply this property. You see, sine inverse minus, this is the property, sine inverse minus x is minus sine inverse x. So according to this property, I can write it minus of sine inverse 1 by root 2. Minus is taken out, not simply, it is taken out according to this property. Sine inverse minus x is minus of sine inverse x. So minus sign taken out, minus will remain as it is. Then we have to see the number corresponding to what angle in sine. 1 by root 2 in sine, it is the angle, it is corresponding to angle pi by 4. So I can write it sine pi by 4. Then again, under by this property, sine inverse and sine cancel, answer is minus pi by 4. So this is the principal value of the given function. Then I am taking for cos, one is taken with positive value of x, another taken with negative value. As I said in previous example, for positive value, you just have to see the number corresponding to what angle in cos. In cos root 3 by 2 corresponding to pi by 6. So it is cos pi by 6, and cos inverse cos cancel under this property. Cos inverse cos cancel, answer is pi by 6, and this is the solution. This is the value of the principal branch for the given function. The second is cos inverse negative, and when negative we must see this property. This property is for negative angle. For cos inverse we have here cos inverse minus x is pi minus cos inverse x. So by this property I can write pi minus cos inverse root 3 by 2. It is written by this property. See clearly, try to understand. Cos inverse minus x is pi minus cos inverse x. So cos inverse negative is pi minus cos inverse root 3 by 2. Then now we have to see this value, this number corresponding to what angle in cos root 3 by 2 in cos pi by 6. Then cos inverse cos cancel, pi minus pi by 6, you take LCM, 6 pi minus pi, finally it is 5 pi by 6, and this is the principal value of the given function. Sin cos, now I am taking for 10. For 10 I have taken one positive, another negative, and as I said, for positive you just have to see the number corresponding to which angle. In 10 root 3 is corresponding to pi by 3, so it is 10 pi by 3, and by this property 3 I have written here. 10 inverse and 10 cancel, so the answer is pi by 3, which is the principal value of the given function. Now coming to this negative value of x. For negative we must see the property. 10 inverse minus x is minus 10 inverse x, so I can write it minus of 10 inverse 1 by root 3. Minus c is not simply taken out, it is taken out by this property according to the property, remember. Now 1 by root 3 is 10, how much? The number 1 by root 3 in 10 row 1 by root 3 is corresponding to pi by 6. Then 10 inverse 10 can cancel, answer is pi by 6. This is the value of this is the principal value of the given functions. For 10 also taken now, sin cos 10 I'll take for cot. For cot positive we have to see the angle. Positive root 3 in cot root 3 pi by 6. Then cot inverse cot cancel, answer is pi by 6. This is the principal value of the given function. Then here for negative we must see the property. For cot negative value of x, this is the property. Cot inverse minus x is pi minus cot inverse x. Cot inverse minus is pi minus cot inverse x, so pi minus. Then again we have to see the number 1 by root 3 is in cot corresponding to which angle? It is corresponding to pi by 3. So we can write cot pi by 3, then like before, cot inverse cot cancel by property 3, and then take LCM, it is 3 pi minus pi, finally 2 pi by 3, which is the principal value of the given function. So for cot also we have done now. Sec, for sec, one is for positive value of x, another for negative value of x, and for positive value of x we know only we have to see the number corresponding to which angle. You see in sec 2 is corresponding to pi by 3, sec pi by 3, then sec inverse sec cancel, answer is pi by 3. This is the principal value of the given function. For negative we must see the property. For negative sec inverse, this is the property. Sec inverse minus x is pi minus sec inverse x, so we can write pi minus sec inverse root 2 according to this property. I have written. Now I have to see the number root 2 in sec root 2 corresponding to pi by 4. So sec pi by 4, and this is getting cancel, pi minus pi by 4. Then take LCM, 4 pi minus pi, it is 3 pi by 4. This is the principal value of the given function. So for sec also done. Now taking for cosec, one for positive I'll take, one for negative. Cosec inverse positive root 2, positive we have to see the number root 2 in cosec, so root over 2 in cosec is corresponding to pi by 4, so cosec pi by 4. Cosec inverse cosec cancel, answer is pi by 4, which is the principal value of the given function. And then cosec inverse negative. For negative we must see the property. This is the property for cosec inverse. Cosec inverse minus x is minus, so we can take out the minus. Cosec inverse 2 by root 3. Minus is not simply taken out, remember minus is taken out according to the property. Cos sec and cot in one group, pi minus group, and remaining is another group in which you can directly take out the minus. So I have applied the property, and then the number 2 by root 3 in cosec 2 by root 3 is corresponding to pi by 3. So cosec pi by 3, and then this is getting cancelled, answer is minus pi by 3, and this is the principal value of the given function. Now whatever I have explained with examples, it is covering the whole exercise 2.1. Every question from exercise 2.1 you can solve easily with the concept given here. Now I am solving some questions. Now in this question, just now what we have learned, exactly same thing, only 3 functions joined together with plus sign, maybe with minus sign also in other questions. So here this is positive value, and tan inverse 1, in tan 1 is the value of pi by 4, but in the second one you see it is negative. For negative you must apply the property. For cos inverse you see cos inverse minus is pi minus cos inverse, so this will be pi minus cos inverse. And for this sin inverse you must apply the sin inverse property, and sin inverse minus is minus sin inverse, so minus will keep in bracket. Then this is getting cancelled, pi by 4 plus pi, and cos inverse 1 by 2 in cos corresponding to pi by 3, and minus into plus into minus will be minus sin inverse 1 by 2 in sin is corresponding to angle pi by 6. Then this is getting cancelled, this is also getting cancelled. Finally we are getting like this, and then if we take LCM we will get the answer. LCM is 12, 4 3s are 12, 12 1s are 12, 3 4s are 12, 6 2s are 12. If we simplify you will get the answer. So this is how we solve. We find the values of trigonometric functions, that is actually the principal value of the trigonometric functions. Then taking another question in which first one is positive, second one is negative. So for positive we have to just choose the value tan root 3, in tan root 3 corresponding to pi by 3, so it is tan pi by 3. Minus is common now, and for sec inverse you must negative you must apply the property. You see the property is here, sec inverse minus x is pi minus sec inverse x, so this will be pi minus sec inverse x, x is root 2. Tan inverse tan cancel here, minus pi, minus of minus will become plus, sec inverse 2 in sec 2 is corresponding to angle pi by 3, sec pi by 3. Then this is getting cancelled, pi by 3 minus pi plus pi by 3. You take LCM, LCM is 3, pi minus 3 pi plus 1 pi. So final answer is I think minus pi by 3. So we can, any question given to find the value, actually it is the principal value. We can, if we know only this two property, mainly this property, this table you already know, which you have learned in class 10, even in 11. And this property is very simple. Every function in its inverse gets cancelled. So any question to find the value we can easily solve it if we just know this property. And this property in a second you can memorize. In a second you can memorize. The pattern is cos secant cot in one group and the remaining is another group. Cos secant cot pi minus, remaining directly minus take out. And in this 3 their range is 0 to pi. And for this group range is minus pi by 2 to plus pi by 2, and I have already explained how to write the intervals, where to write the close and where to write the open interval. Now taking some more examples, it is from exercise 2.2 question number 16. You are asked to find the value of this function given. We have learned here this property that sin inverse sin can be cancelled. So here if we can cancel sin inverse sin, then the resulting value we are getting is 2 pi by 3. Now whatever value you get, it must lie in the range of the function. Sin inverse range is minus pi by 2 to plus pi by 2. Now this value you got, is it lying in the range minus pi by 2 to plus pi by 2, close interval for sin. This value, pi value 180, 180 by 3 is 60, 60 to the 120. Yes, 120. Is it lying between minus 90 to plus 90? Pi by 2 is 90. So 120 is not lying. That means this solution is not correct. And to get the correct solution, we must reduce this angle. So I can reduce it like this. See, 2 pi by 3 we can write pi minus pi by 3. Take LCM and see it is correct or not. When numerator is smaller, remember, we will have minus here. If numerator is bigger, then we will have plus here, just for basic idea. Now, after expanding, you take LCM and see the number is correct or not. If we take LCM 3 pi minus pi is 2 pi, so it is correct. And then we have learned in class 11, sin pi minus theta is equal to sin theta. Sin pi minus theta is equal to sin theta. It is positive in second quadrant. So we will have sin inverse sin pi by 3 according to this. And then sin inverse sin cancel, answer is pi by 3. And this value, is it lying in the range? Sin inverse range is minus pi by 2 to plus pi by 2. Now this value is lying in the range. So this solution is correct. So this is the complete solution. This solution is correct because the value of sin inverse what you have got must be in the range, and it is lying. Pi by 3 is 60, so it is lying between minus 90 to plus 90. This is correct. The next question is question number 17 from 2.2 only. It is tan inverse tan 3 pi by 4, and according to our this property, tan inverse tan cancel will be equal to only x. So here if we cancel tan inverse tan, we will have 3 pi by 4. And is it lying in the range of tan inverse? Tan inverse range is minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. For tan will be open interval because tan 90 is not defined. Now 3 pi by 4. Pi is 180 by 4, 45. So it is 135. Is it lying between minus 90 to plus 90? Pi by 2 is 90. No, this value is not lying. So this solution is not correct. And to get the correct solution, we must reduce this angle. So it will be like this. Tan, I can write it pi minus pi by 4. You take LCM and see it is correct or not. 4 minus is correct. 4 pi minus pi is 3 pi, correct. And then we will apply the formula tan pi minus theta is equal to minus tan theta, which we have learned in class 11. So according to this, it is minus of tan pi by 4. Now tan inverse negative, we must see the property of negative value of x. Tan inverse negative is minus tan inverse. So according to this property, minus will be taken out, minus of tan inverse tan pi by 4. And then if we cancel by this property, tan inverse and cancel, answer is pi by 4. Is it lying in the range of tan inverse? Range of tan inverse is minus pi by 2 to plus pi by 2. Yes, this is lying in the range. So this solution is correct. This is the correct solution, correct value of the given function. The next question I have taken, question number 19 also from exercise 2.2. It is also about the principal value of the function. So cos inverse, we have this is the property, cos inverse cos gets cancelled, and if you cancel cos inverse cos, remaining 7 pi by 6. Now the value you got must be in the range of cos inverse. The function is cos inverse, and cos inverse range is 0 to pi. It is closed interval. Now see it is correct or not. Pi is 180 by 6 is 30. 3 7 are 210. Is it lying in between 0 to 180? No. 210 is going beyond. So this solution is not correct. And to get the correct solution, you must reduce the angle. This angle will reduce it. Numerator is bigger, so it will be plus pi by 6. Now take LCM and see it is correct or not. Yes, if we take LCM, it will be correct. And then we will apply here cos pi plus theta, which we have learned in class 11. Pi plus theta is in third quadrant. Cos will be negative. So it is like this, minus cos pi by 6. The problem is again cos inverse negative, and for cos inverse negative you must apply the property cos inverse negative. Cos inverse negative is pi minus cos inverse positive, so it will be pi minus cos inverse positive. So according to this property only I am writing here cos inverse negative is pi minus cos inverse positive, and then we can cancel function in its inverse and then take LCM 6 pi minus pi, finally 5 pi by 6. It is lying in the range. You can calculate and see pi is 180, you put the value 180 and calculate and see it is correct. So this is the solution for the given function. This is what solution, what value? It is the actually principal value of the given function. Again in miscellaneous exercise we have some questions related to principal values. So miscellaneous question number 1, cos inverse cos 13 pi by 6. The same thing again. According to this property, if we cancel cos inverse cos, the resulting answer remaining is 13 pi by 6, and this value 13 pi by 6, is it lying in the range cos inverse range 0 to pi close interval? This value is not. You can calculate and see pi value 180, put 180 and can calculate and see the value. It is not lying in the range, so this solution is not correct. And to get the correct solution, now we have to reduce the angle. What we can write, 6 to the 12 plus 1. So it is like this. 6 to the 12 pi plus pi 13 pi. So it is correct. And then we will apply the formula. We have learned cos 2 pi plus theta is equal to cos theta, which we have learned in class 11. 2 pi plus is in first quadrant, positive. Then it is cos inverse cos theta pi by 6. And then you cancel according to the property cos inverse cos, resulting value is pi by 6. Is it lying in the range of cos inverse? The question is cos inverse, so cos inverse range 0 to pi by 0 to pi, and this value it is lying, and hence it is the correct solution. Then we have next question, miscellaneous question number 2. It is also about the principal values. The same concept again. Tan inverse 10, if we cancel, we are getting 7 pi by 6. And is it lying in the range of tan inverse? Question is tan inverse. So the value what you get must be in the range of tan inverse. Tan inverse range is minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. Open or close? Tan 90. Tan 90 not defined. So not defined is open. And this value is not lying. You can calculate. Pi is 180 by 6 is 30, 210. It is 210, not lying between minus 90 to plus 90. So this solution is not correct. And hence to get the correct solution, we must expand the angle. 7 pi by 6, it will be pi plus pi by 6. Numerator is bigger, as I said. Numerator bigger, always try with plus sign. Numerator smaller, you try with minus sign. Now take LCM and see it is correct or not. 6 plus 1, 7, correct. And then we will use the formula. Tan pi plus theta is 10, third quadrant, 10 positive. It will be tan theta only. Third quadrant, 10 positive. So we are getting tan inverse 10 pi by 6. Tan inverse 10 cancel. Answer is pi by 6. And it is lying in the range of tan inverse. And hence the solution is correct. The correct solution is, the correct value is pi by 6. Then we have one more question from miscellaneous. No, there is no more question. All the questions related to principal values we have finished, we have covered within this video. Any question, if you have the concept given, any question you can easily do. And for principal values, you remember, you mainly need to know this property only. This one is very simple, you can memorize in a second. And you must have the knowledge of this, the trigonometric table, values for the trigonometric functions. So this is the end of this lecture, and in next lecture 2 I will give the complete solution of all the remaining questions in exercise 2.2 of textbook and even the miscellaneous.